Science in pajamas. Boop, 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 boop. Alright, so today we're going to talk about acceleration, and we're just going to kind of do an overall review of it. There will be videos that follow that'll talk about, like, with examples, how to solve it, all that good stuff. But today we're simply going to talk about what it is and how to interpret it. So acceleration what this is a change in velocity. Now, write that down. It is a change in velocity. Now, the next question becomes, okay, well, what does that mean? Let's think about what the term velocity means. Velocity velocity is speed in a given direction. All right. So if velocity is speed in a given direction and acceleration is a change in velocity, that means that acceleration is a change in the speed or direction of an object. Hi, Rick. Hi. Yeah, this little guy, he heard a noise outside, so he accelerated outside in order to go bark at you, didn't you? Yes, you did. All right. So what constitutes then an acceleration? An acceleration, based on what we know about its definition and the definition of velocity, would therefore be a change in speed. So that means an acceleration would be if an object speeds up or if it slows down. Because whenever an object is speeding up or slowing down, it has to change its speed to do that. But also remember, velocity includes direction. So another way to look at acceleration is if there is a change in direction. Changing direction is a form of acceleration. So here I have a tennis ball. Here I have a tennis ball. It is at rest. It has zero velocity. I rode it. It started moving. It went from no velocity to some amount of velocity. It experienced an acceleration. You can also do it the opposite way. It's speeding, and I stop it. So it slowed down, and it also changed direction. It went from here, and then it bounced back a little bit. Even this guy. It's changing direction. Even if I throw it at the board, its direction and speed will be towards the board. It's hit the board, causing it to slow down, and then it sped up away from the board, so it changed its velocity twice, first by slowing down, then by speeding up, and then again as it changed direction. So all of these constitute acceleration. Now acceleration has an equation, and that is acceleration equals the final velocity minus the initial velocity, because remember, it's a change in direction, over the amount of time needed to make that change. Now, the unit for this would be meters per second squared. And the reason why we get the meters per second squared is because if we look at this and we look at the units that are associated with these, velocity can be meters per second minus some other value in meters per second over time, which is in seconds. So you end up with a meters per second, which ends up being meters per second squared. So that's how we derive the units. But this is our equation. There will be some examples of it in another video, because I'm actually going to sit down, have a big whiteboard on the ground, use a document camera, and show you how we solve them. I'm not going to do that here. I just want to keep talking a little bit about a few other things. All right. I'm going to show you how to derive those equations in another video. Let's talk about position time graphs. Now, first of all, going back to acceleration is just like before, it can be positive or negative. And all that means is the direction that the acceleration is occurring in. So if we have a car, and it is moving forward and it speeds up. So maybe it was going 10 meters per second, and then it sped up to 20 meters per second. Now, what that means is it is accelerating in the forward direction because it is speeding up. Its acceleration is moving it forward, even or at a faster rate. Maybe this took 2 seconds to do. Now, if we were to plug that into the equation, final velocity is VF, so that's our final. Here's our initial, and this would be our time. So final minus initial over time. So 20 minus 10 would give us 10. Divided by 2 seconds. And the acceleration would be 5 meters per second. Now, it's a positive number. We know it's positive because it's speeding up. That means that the direction of the acceleration is in the forward direction. Now, that would be different in a certain case. What if it was already moving at 20 meters per second and it slowed down to 10 meters per second? So it took 2 seconds to do this. So this time it is slowing down. So that means that this is now the initial, this is now the final, and this is still the time. So let's plug it in. Final minus initial would be 10 meters per second minus 20 meters per second divided by 2 seconds. 10 minus 20 would be negative 10 divided by 2 seconds would be negative 5 meters per second squared. Now what that means, that negative value means that the acceleration is actually going in the opposite direction, and that's causing the car to slow down. A backwards acceleration or a negative acceleration would slow down an object. A positive acceleration would cause it to speed up. All right, let's see, talked about that. Now let's talk a little bit about position time graphs. I know we mentioned them before with velocity. Now remember, we said that velocity, we usually saw that as a straight line, and that meant that it was going at a constant velocity, a constant speed in that direction. If it changed like that, then that means that it changed speed. Now, a lot of times, what we see with acceleration is more a parabolic shape. So it can go like, oh, that's still displacement over time. So we would see something like that. And the reason for this is if an object is going at a certain speed, it's going to be traveling at a constant amount. But if you are accelerating, then that means your speed is changing, which is why the slope of the line keeps changing. Now, when you see a nice parabola like that, it means it's undergoing constant acceleration. That means that at each point of its travel, it is increasing, or, well, it's changing its velocity by the same amount. So maybe the car started at The car started at 10 meters per second. If it had a constant acceleration of 5 meters per second squared, then that means after each second it is accelerating or speeding up by this amount. 5 meters per second squared. So at the 0 second mark, when it's just starting, it's already going at 10 meters per second. After 1 second, it would be going 15 meters per second. After 2 seconds, it would be going 20 meters per second. After 3 seconds, it would be going 25 meters per second. So constant acceleration means that at each moment it is speeding up, in this case, by the same amount. So its acceleration was 5 meters per second squared. After every second, it should be going 5 meters per second faster. So start at 10, 5 meters would be 15 meters per second. At another, it would be 20 meters per second. At another, 25 meters per second. Now the same thing applies even if there's a negative acceleration. So what we see with a negative acceleration is simply an upside down parabola. And again, if it's constant acceleration, even if it's constant negative acceleration, it means that it's slowing down by the same amount each time. So maybe this time the car was experiencing a negative 5 meters per second squared acceleration. Maybe it started at 30 meters per second. That was at our initial time, so 0. After 1 second, it'd be 30 plus negative 5, it'd be 25 meters per second. After another second, it'd be 25 plus negative 5 would be 20 meters per second, and so on and so on. Now there's another kind of acceleration that I do want us to mention. It's called free fall. Now free fall it describes the motion of an object when the only force acting on it is the force of gravity. So if I just hold this up, it is at rest, meaning that it's not moving. It has no velocity in the beginning. So an object at rest is not moving. But if I let it go, it starts to move. Because at that point, the only force acting on it is the Earth's gravity pulling it down. And how that works is, well, I mean, we'll get into the idea of gravity later, but when I let it go, right now I'm holding it up. If there's nothing holding it up, not even me, the then gravity's going to pull it down to the ground where it would stay there. I didn't throw the ball down. I didn't, shoot it down. I just simply let it go. All right, so we call this free fall. And it's called free fall because, as we said, the only thing acting on it is, in this case, gravity. Even if I was to toss this up, it's still considered free fall because if I throw it up here, it'll accelerate upwards. It'll actually stop for a fraction of a second. It'll have no velocity. So for a fraction of a second, at the peak of its toss, it's at zero, like when it's at rest. And then it starts accelerating downwards again. So because it still has that highest point of being at zero, we still consider it free fall. Because once I let go of it, again, there is nothing else acting on it except for gravity. Now, gravity is fairly constant, which is always a good thing, right? Yeah. And we know that the acceleration due to gravity is roughly negative 9.8 meters per second squared. Notice it is a negative. Why is that? Well, think about the way gravity pulls. Which direction does gravity pull an object? Does it pull it up? Does it pull it to the right? Does it pull it left? Or does it pull it down? It pulls it down. So since gravity is pulling the object down, it's experiencing the negative acceleration. So you can look at this in terms of, like we said, if I threw a ball up in the air. So here's me. Aren't I so cute? If I throw a ball up in the air, it's going to go up. It'll hit the peak, and then it'll come back down. Now, at this peak, it goes up, hits the peak, comes back down. At that peak, the interesting thing about it, like we said, it's zero. It is, for a fraction of a moment, it has zero velocity. It doesn't move. It actually pauses for a moment as the acceleration is changing. As it's going upwards, it is experiencing the negative acceleration of 9.8 meters per second squared. So it's experiencing the downward acceleration, which causes its velocity to decrease. In other words, it's going to slow down, which, yeah, that makes sense. I throw it up, slows down, it stops, and then it starts falling again. And as it starts falling, it still has the same acceleration because, again, only gravity is acting on it. But this time, the velocity is going to increase. All right. So, like I said, I just kind of wanted to talk a little bit about those. There will be some videos coming up where we solve problems, we derive equations. But yeah. All right, you guys. Hope that was helpful, and just in terms of explaining it. And in the meantime, you guys just stay awesome, stay amazing, and stay safe. All right. Talk to you later.